Most businesses already make forecasts every day. They estimate sales, staffing, inventory, delivery dates, maintenance needs, project costs, and cash flow. The problem is that many of those decisions are still based on spreadsheets, averages, intuition, or whoever has the most experience in the room. Predictive AI is not about magically knowing the future. It is about using the data you already have to make better decisions before the outcome occurs. When many people hear the words artificial intelligence today, they immediately think about ChatGPT, copilots, assistants, and large language models. Those systems are important, but they represent only one part of AI. Generative AI is primarily about creating something new. It may create text, summarize a document, generate an image, write code, or answer a question. Predictive AI asks a different question. Given what we already know, what is likely to happen next? That distinction sounds simple, but it changes the entire business conversation. Imagine a distributor with 10 years of order history. A generative AI application might summarize customer notes, create an explanation of why an order was delayed, or help an employee write an email to a customer. A predictive system might estimate how many units of a product will be required next month. Those are very different capabilities. One creates information, the other estimates an outcome. And forecasting is a specific form of prediction. Forecasting usually adds an important dimension, time. Instead of simply asking, what is likely to happen, we are asking, what is likely to happen next week, next month, next quarter? A manufacturer might forecast demand. A hospital might forecast staffing requirements. A logistics company might forecast shipment volumes. A finance department might forecast cash flow. A service organization might forecast support workload. One mistake organizations can make is treating generative AI as though it replaced traditional machine learning and predictive analytics. It did not. LLMs are extremely useful, but they did not suddenly make historical transaction data, statistical modeling, classification, regression, or forecasting irrelevant. The useful question is not, should we use generative AI or predictive AI? The useful question is, what business problem are we trying to solve, and which AI capability fits that problem? Sometimes the answer is generative AI, sometimes it is predictive AI, and increasingly, strong enterprise applications may use both. Predictive AI is an umbrella term. Under that umbrella are several different kinds of problems, and the easiest way to understand them is through the business question being asked. Suppose a sales manager asks, how many units are we likely to sell next month? That is primarily a forecasting problem, because we are predicting a value across time. Now consider, what will this project ultimately cost? That is more naturally a regression problem. We want the model to estimate a numeric value. If the question becomes, is this customer likely to cancel? Now we are usually dealing with classification. The model may classify the customer as likely to leave or unlikely to leave. You can extend that idea further. Will this machine fail during the next 30 days? Will this invoice be paid late? Is this transaction suspicious? Will this shipment miss its promised delivery date? These can all become classification or probability scoring problems. The terminology matters, but not because everyone in the business needs to become a data scientist. It matters because the type of question affects how the system should be designed and evaluated. A forecast might be off by 8%. A maintenance model might assign an 80% probability of failure. A churn model might rank customers from highest risk to lowest risk. Those outputs are not interchangeable. They support different decisions. Problems start when organizations jump directly to an algorithm before clearly defining the outcome. Someone says, "We want to use machine learning." That is not a business problem. Someone says, "We want better forecasting." That is better, but still incomplete. A much stronger definition would be, "We want to estimate weekly demand for our 20 highest volume products 4 weeks in advance, so purchasing can reduce stockouts without dramatically increasing excess inventory." Now we know what is being predicted. We know the time horizon. We know who acts on it. And we know why it matters. That gives us a simple rule. Define the decision first. Define the prediction second. Choose the algorithm later. That sequence keeps predictive AI focused on business value instead of becoming a science experiment. Many organizations assume their first predictive AI project begins with collecting massive amounts of new data. Sometimes it does. But very often, the more practical starting point is much simpler. Look at what the organization has already been recording for years. In a Microsoft-centric enterprise, that data may already exist in SQL Server, Azure SQL, an ERP system, a CRM system, manufacturing systems, order entry applications, financial applications, inventory systems, service applications, telemetry platforms, application logs, or custom .NET business systems. Every transaction may be recording part of the history of the business. Orders, prices, quantities, dates, customers, products, downtime, repairs, returns, payments, projects, labor hours, delivery times, service calls. Taken individually, those records describe what happened. Taken together, they may contain patterns that help estimate what happens next. Consider a manufacturing operation. The company may already have several years of production history, maintenance records, machine telemetry, quality inspections, shift information, and downtime records. The immediate question should not be, what new AI data platform do we need to buy? A better first question is, what decisions are we already making that this historical data might improve? That might expose opportunities around maintenance, production scheduling, staffing, quality, inventory, or delivery commitments. But having data is not the same thing as having usable training data. Historical systems contain problems. Values change meaning. Fields are repurposed. Processes change. Products get renamed. Employees enter data differently. Systems are replaced. Missing values accumulate. Business rules change. A column that looks mathematically useful may not represent the same business concept consistently across 10 years. This is where experienced database professionals, business analysts, developers, and subject matter experts become extremely important. They understand what the data actually represents. Predictive AI does not eliminate the value of business knowledge. It increases it. The practical opportunity is often not collect everything. It is extract more value from the information the business is already collecting. Once people stop thinking about predictive AI as one specific algorithm, the number of business opportunities expands quickly. The easiest way to find those opportunities is to look at recurring uncertainty. Where does the business repeatedly ask, how much, how many, when, which one, how likely? Start with demand. How much product will customers need? That affects purchasing, manufacturing, inventory, logistics, warehouse capacity, and cash. Sales forecasting extends the same idea into products, regions, customer groups, or channels. Finance may forecast revenue, expenses, cash flow, collections, or payment risk. Operations may forecast workload. How many service requests will arrive tomorrow? How many employees will be needed next Tuesday? How much warehouse activity should we expect during the holiday season? Manufacturing creates another family of opportunities. When is equipment likely to fail? Which production runs are at higher risk of quality problems? How much material is likely to be consumed? Which orders are most likely to finish late? Customer behavior creates another category. Which customers are showing signs of leaving? Which accounts may reduce purchasing? Which invoices have a high probability of late payment? Which customer interactions warrant attention from a human employee? Then there are projects. How long is this project likely to take? What will it ultimately cost? Which projects are developing patterns associated with schedule problems or budget overruns? And risk can appear nearly anywhere. Fraud, default, quality failures, warranty claims, late shipments, anomalous transactions, equipment failures, unusual system behavior. Not every one of these ideas will become a good AI application. Some will not have enough data. Some outcomes happen too rarely. Some processes change too frequently. Some predictions provide no useful lead time. And sometimes the organization already has a simple rule that works perfectly well. AI is not automatically the better answer, but the opportunity list is usually much larger than people expect. A useful exercise is to walk through each department and ask, what are we repeatedly estimating today that we could measure tomorrow? That question begins turning normal business uncertainty into potential predictive AI use cases. A predictive model does not know the future. That statement sounds obvious, but it is one of the most important ideas in this entire topic. A forecast is an estimate. A risk score is an estimate. A probability is an estimate. And every estimate contains uncertainty. Suppose a system forecasts next month's demand at 10,000 units. The dangerous interpretation is, we will sell 10,000 units. The better interpretation is, based on the available data and the patterns this model has learned, 10,000 units is our current best estimate. Depending on the system, we may also be able to communicate a range around that estimate. Perhaps demand is most likely to fall between 9,000 and 11,000 units. That range can sometimes be more useful to management than a single number presented with false precision. Accuracy also depends on assumptions. Models learn from historical relationships, but businesses change, customers change, competitors change, prices change, regulations change, supply chains change, economic conditions change, and sometimes something happens that has little useful precedent in the training data. This is why a model that performed extremely well last year can gradually become less useful. The technical term may be model drift or concept drift, but the business symptom is simple. The predictions stop matching reality as well as they used to. That means a production predictive system cannot simply be trained once and forgotten. Someone needs to compare predictions against actual outcomes. Someone needs to watch error. Someone needs to determine whether the input data changed. And eventually, someone may need to retrain, replace, or redesign the model. Human judgment also matters. A model may know that sales typically increase by 15% during a certain period. It may not know that your largest customer just announced a plant shutdown, unless that information is incorporated into the system. A purchasing manager may know something the model does not. The strongest predictive applications, therefore, do not pretend uncertainty disappeared. They make uncertainty visible enough that people can use it intelligently. The objective is not perfect foresight. It is better decision-making under uncertainty. A highly accurate prediction can still be commercially worthless. That sounds counterintuitive, but it is fundamental to predictive AI. Imagine a model that predicts an event with 92% accuracy. Very impressive. But nobody in the organization changes a decision based on that prediction. No workflow changes, no employee acts differently, no cost is avoided, no revenue is protected, no risk is reduced. What did that 92% accuracy actually accomplish? Potentially, nothing. Now consider a different model. Suppose it is only 75% accurate, but it can identify likely inventory shortages 2 weeks before they occur. Purchasing can investigate, suppliers can be contacted, production can be adjusted, alternative inventory can be found, customers can receive better delivery commitments. That imperfect prediction may produce significant business value. This gives us a much better way to think about predictive AI. Prediction, decision, action, business outcome. Each step matters. If the prediction never reaches a decision maker, the chain breaks. If the prediction arrives after the decision has already been made, the chain breaks. If nobody trusts the prediction enough to act, the chain breaks. If the organization cannot take any meaningful action, even when the prediction is correct, the chain breaks. Lead time, therefore, matters enormously. Predicting that a machine will fail 5 seconds before it fails may be technically interesting. Predicting the same failure 7 days early may change maintenance scheduling, parts availability, staffing, and production planning. The business value may come primarily from those 7 days. This is why model accuracy should never be the only success metric. Technical teams may measure error rates, precision, recall, mean absolute error, or other statistical metrics. Those are important. But leadership should also ask, did stockouts decline? Did downtime decline? Did overtime decline? Did forecast error improve over the old method? Did collections improve? Did fewer projects exceed budget? Did planners make better decisions? The model is not the business outcome. The model is one component in a decision system. And when we evaluate predictive AI that way, we stop optimizing for impressive demos and start optimizing for useful operations. The best predictive AI opportunities usually share a recognizable pattern. You do not need to begin with algorithms. Start with the business process. First, look for a repeated decision. Something happens again and again. A buyer decides how much inventory to order. A manager decides how many people to schedule. A maintenance team decides which machine should be inspected. A project manager updates a completion estimate. A finance team estimates collections. Repeated decisions give us repeated opportunities to learn. Second, look for historical data. Do we have records showing what happened before the decision? And do we eventually record the actual outcome? If we want to predict project cost, for example, we need historical information about projects and what they ultimately cost. Third, define a measurable outcome. Improve operations is not a predictive target. Predict whether an order will ship late is much more specific. Forecast weekly unit demand 4 weeks ahead is specific. Fourth, determine whether there is enough lead time to act. This is frequently overlooked. Suppose we can predict that a customer is likely to leave. When? 6 months before the customer leaves? 2 weeks before? 30 seconds before the cancellation request arrives? Those are completely different business opportunities. Fifth, ask what happens if the model is wrong. False positives have consequences. False negatives have consequences. Over-forecasting demand may create excess inventory. Under-forecasting may create shortages. Predicting too many machines as high risk may waste maintenance resources. Predicting too few may allow failures. That means the best model is not automatically the one with the highest generic accuracy score. The best system balances prediction quality with the economics and operational consequences of the decision. So my starting framework is intentionally simple. Repeated decision, historical data, measurable outcome, enough lead time to act. If those four conditions exist, the opportunity deserves a closer look. Then we can evaluate data quality, frequency, business value, technical feasibility, model options, workflow integration, and production requirements. That is where a focused opportunity assessment becomes valuable. You do not need to begin by rebuilding the enterprise data platform. You do not need to promise an autonomous AI transformation. Start with one useful decision. Use real historical data. Build a focused prototype. Measure whether the prediction improves anything. If it does, then start engineering the surrounding application for real business use. Forecasting and predictive AI are ultimately about using historical information to make better decisions before the outcome occurs. The organizations that connect good data, business knowledge, realistic uncertainty, and an actionable workflow will get far more value than those chasing prediction accuracy alone. You can explore more practical enterprise AI resources at ain.net.com. Thanks for watching.